Hello. Today I am going to be telling you all about quadratics. Wait, that's not actually true. I'm going to be telling you some ways to solve quadratics. I'm going to be talking about factorising, the quadratic formula, and solving them graphically. We're going to start off pretty easy. I'm just going to go through some questions and explain how they're done. Excuse my terrible handwriting. So anyway, here we have x squared plus 5x plus 6 equals 0. To do this, we are going to factorise. That means we have to find two numbers which multiply to get this last number here, the 6, and add to get this 5. What gets us 5 and what gets us 6? So factors of 6, we've got 1 and 6. We've got 3 and 2. Here, 3 plus 2 is 5. 1 plus 6 is 7. So we're going to use 3 and 2. Because 3 and 2 adds to 5 and multiplies to 6, we can put this in the form x squared plus 3x plus 2x plus 6. It doesn't matter which way around these two are, you'll get the same answer either way. Then we can draw a line down. That is a wonky line. Here we find that the highest common factor of both these, so the highest common factor is x, because we've got x squared here, so we've got an x, and we've got an x here. Imagine there's a 1 here, because it's x squared, or x on its own always has a 1. We just don't put that because 1 times x, of course, is x. So the highest common factor is x. Then we put a bracket. Because we've divided everything by x, we put that in the bracket. So whatever x multiplies to get what we got to start with. So to get x squared, we need x times x, because that's x squared. And then to get 3x, we need a 3 times the x, so plus 3. Because if you expand that out, you get x squared plus 3x. Now we do the same on this side, and we should get the same bracket, because we've got 2 and 6. The highest common factor is 2. Put bracket. Then we have the same, x plus 3. Because if we expand that out, we get 2x plus 6. So now we have x plus 2, x plus 3. Now this all equals 0, as it says over here at the start. It equals 0. So this multiplied by this equals 0. So each one on its own must also equal 0, because, well, you can't get 0 unless you multiply by 0. So x plus 2 equals 0, and x plus 3, that is the ugliest x ever, equals 0. So if x plus 2 equals 0, we can just solve that like a normal equation. We can subtract 2 from each side. So x equals minus 2. Here, 3, we can do the same. We get x equals minus 3. So in all of these, we have got x equals minus 2 and x equals minus 3. And x has two solutions because it's a quadratic. With a cubic, it'll have 3. With a power of 4, it'll have 4, and so on and so on. So this is our answer for solving this. X equals minus 2 and x equals minus 3. If I can't circle. Anyway, we'll go on to the next one. Pause the video and have a go at this one by yourself. So here we've got x squared minus 3x minus 4 equals 0 again. If we find factors of minus 4, we have minus 4 and 1. We have minus 2 and 2, or, well, 4 and minus 1, and that's that. So the ones we're going to want to use are minus 4 and 1, because we want to make minus 3. Minus 4 plus 1 is minus 3. So we have x squared, that is disgusting, minus 4x plus 1x, which is just x, minus 4 equals 0. So then again, we can do our little line. We're going to go through it. So we have x here, bracket, x minus 4. And here again, we just have 1, x minus 4. It's positive 1. So we have x plus 1, x minus 4. So our answers are going to be x equals minus 1 and x equals 4. Well done if you got that. We've got one more of these ones and then we go on to some that are a bit harder. Give this one a go as well. Here we've got x squared plus 2x minus 15 equals 0. What makes 15 or minus 15 that also makes 2? Well, we've got 1 and minus 15, we've got minus 1 and 15, and we've got 5 and minus 3, we got minus 5 and 3. The ones that are going to make 2 is 5 minus 3, because that makes 2. So we've got x squared plus 5x minus 3x minus 15 equals 0. Let's do our thing again. We've got x plus 5 and minus 3x plus 5. Notice how these are both minus or negative, so we can put minus 3 on the outside, then x plus 5 on the inside, because minus 3 times positive 5 is minus 15. Because a negative and a negative equals a positive, but a negative and a positive equals a negative. So we now have x minus 3, x plus 5, and they both equal 0. So here x is going to equal 3 and x is going to equal minus 5. Cool. That's not too bad, is it? Now it gets a little bit more difficult. Here we have to use what we call the AC method. Now it's not terrible. I know it says factorize here, but we're going to solve because I want to solve. It's pretty much the same. We have been solving by factorizing. This is the factorizing step, and solving is just the one step after, so it's not any different really. So anyway, here we have 2x squared plus 5x plus 2. Now notice we have a coefficient in front of the x squared, which is 2. And we have to do something with that. So we are going to it's called the AC method because we've got A, B, and C. And what we want to do is we multiply A by C. I just realised I can't draw off the page. So 2 times 2 is 4. So what we want to do now, pretend that's 4, we want to find something that adds up to make 5 and multiplies to make 4, which is not going to be 2 and 2 because that added together makes 4. It's going to be 4 and 1. So we can now write that out, 2x squared plus 4x plus x, and then we go back to the 2 because that's what it is in the question. We don't use the 4 here because we got the 2 here, got the 2 there, plus 2. And then we can draw our line. Now, the highest one of these is 2x because they both got an x and they both got 2. So 2x bracket, we have an x to get 2x squared plus, and then a 2 to get 4x. Here we just have 1 x plus 2. So we have 2x plus 1 x plus 2. To solve this, we do the same thing. We set it equal to 0. This one, x equals minus 2. This one's a little bit trickier because then we get 2x equals minus 1. So we have to divide it by 2 to get x equals minus 0.5. That's how we do AC method. Let's try another one of those. Pause the video and have a go yourself. So the way we're going to do this one is by, again, doing the AC method. So we get 24. We want to know what makes 24 that also makes 11 when added together. So 24, we've got 1 and 24, got 2 and 12, we've got 3 and 8, we've got 4 and 6. Now we're going to use 3 and 8 because that makes 11. So we have 2x squared plus 3x plus 8x plus 12. Draw down our line. We have the highest one here is just x because 2 and 3 don't have any common factors. So it's just x, and we have 2x plus 3. And here, 8 and 12 have a common factor of 4. And then 2x plus 3. So we get x plus 4, 2x plus 3. So we get x equals minus 4. Remember, we're solving because I want to solve. And then we have x equals minus 3 over 2, which equals minus 1.5. You can leave it in either form, decimal or fraction, it's fine. That does not look like a 3, but it is. Okay, that's what we've got for this one. We'll do another one of these and then we'll go on to graphs. Give it a go yourself again. Here, we've got 3x squared plus 17x plus 10. We multiply the 3a by the 10c, and we get 30. Now 30 has 30 and 1, 2, 15, 3, 10, so on and so on. We want 2 and 15 because 2 plus 15 equals 17, which is what we want. So we can write down 3x squared plus 2x plus 15x plus 10. Now, of course, it's all equal to 0. I just haven't been writing the zeros on because I'm lazy, but it is all equal to 0, and that's why this works. If it's not equal to 0, you need to make it equal to 0. And there's a question later on that I'll show you how to do that, and it's really not difficult. It's just sort of rearrange it all to make it equal to 0. So, here, again, we've just got x, 3x plus 2, and here we have 5 as a common factor, 3x plus 2. So we get x plus 5, 3x plus 2. So we have x equals minus 5, x equals minus 2 over 3, which equals minus 0.6 recurring. So we have this done, minus 5 minus 0.6 recurring, which is probably easier to leave in minus 2 over 3. It does not matter. Now we're going on to graphs, which is a bit more difficult. So a graph, you will sometimes get a table of values with the graphs, which is helpful, but it's not necessary. You can make one yourself. To make a table of values, you just put however many values of x you feel like you need, and then the y underneath. And then to find out y, you just sub in your values for x, which are in ascending order or whatever. So, to work out 11 here, they've subbed in minus 2. Minus 2 squared is 4, because minus 2 times minus 2, because 2 negatives make a positive, is 4. Minus 3 times minus 2 is 6. So minus 6 is plus 6, because, again, 2 negatives make a positive. 4 plus 6 is 10, plus 1 is 11. So we can do it for minus 1. Minus 1 squared equals 1. Minus 3 times minus 1 equals 3. And plus 1. So we have 1 plus 3 plus 1, which equals 5. So here we get 5. Of course, for 0, it's going to be 1, because these aren't going to have anything because they're all going to be multiplied by 0, so it's just plus 1. 1 they've subbed in, they've got 1. Minus 3 plus 1 is minus 1. For 2, 2 squared is 4. Minus 6 is equals minus 2, but plus 1 is minus 1 again. And then for 3, they're back to 1, and 4, they're back to 5. And you'll see this is going to make a curve. So when we go to x is minus 2, y is 11. So let's put that there. When x is minus 1, y equals 5. So let's put that there. I would do crosses, but I'm not precise enough with this thing that I'm writing on. 0, when x is 0, y is 1. When x is 1, y is minus 1. And when x is 2, y is also minus 1. And when x is 3, y is 1. When x is 4, y is 5, etc. So, as you can see, if we join up these dots, which excuse my terrible drawing, but it's going to be awful. Now that's acceptable. Pretend that goes through all the points. Anyway, we'd have a nice clean curve. So this is a nice clean quadratic curve. As you can see, it's lovely. And from here, we can work out a couple of things. We can work out the solutions, which is just where it crosses the x-axis, so what x equals. And here it's looking like 0.5 and 2.5. That's probably not right because my drawing's terrible, but that's roughly what it is. As you can see, that's where it crosses, that's where it crosses. And then the turning point is where it goes down between these. There's another way to work that out without a graph, but yeah, you can work out the turning point. This should probably go down a bit lower, and it's roughly here, which is minus 1.6 for the y value and 1.5 for the x value, so it's 1.5 minus 1.6. It's probably not actually, because this is not precise in any way, shape or form, but you get the rough idea. I'm not going to do any more graphs because, well, they're a bit of a pain, and you can't really try and do them yourself unless you want to draw out one of these axes, which I'm sure you can't be bothered to do. Maybe just practice tables of values, Google questions and stuff just to practice a little bit of graphing. So here we're going to talk about the quadratic formula, which you can do on your calculator or in your head or on the paper, but if it's a calculator paper, it probably wants you to use the quadratic formula, but maybe not. Anyway, first we need to get our quadratic equal to 0, which is what I was talking about earlier. So we have x, I can't write now, x squared minus 3x plus 1 equals 2x minus 4. That's disgusting, so ignore that. So what we want to do is, because we've got negative 4 here, we want to add 4 to get rid of it, and that also adds 4 to this side. So we've got x squared minus 3x plus 5 equals 2x. Now, because we've got 2x here, we want to subtract the 2x to get rid of it, because it's a positive 2x. So that gives us x squared minus 5x, because minus 3 minus 2 is minus 5, plus 5 equals 0. Now, the quadratic formula is quite complicated. It is minus b plus or minus the square root of b squared minus 4ac AC over 2A. Now that can look quite daunting, but really it's not that much to remember. There's no really good way to remember it. You just have to sort of remember it and hope for the best. The plus and minus here is just going to give you your two solutions. So you do one at a time and that'll give you your two solutions. Let's label up. So the coefficient in front of the x squared, which is 1, is the a. The coefficient minus 5 is the b. And the coefficient, or just the one at the end, is c. So we know our number. We know a equals 1, b equals minus 5, and c equals 5. So to start off, let's sub in our values. So we have minus b, which is minus 5. So that's going to be a positive 5. Let's do a plus first. The square root of b squared minus 5 squared and 5 squared are the same, because it's minus 5 times minus 5. So 25 minus, and then we want to do a bracket because we want to do this bit first. It doesn't really matter though. Your calculator will probably do it anyway. 4 times a, which is 1, times c, which is 5, all over 2 times a, which is 1. So that gives us 5 plus the square root of 5, because 25 minus 20, over 2. Now, you probably want to put that in your calculator, because I don't think this is going to be a very nice number. 3.61803 and a load of other numbers. So we probably want to round that to 1 or 2. So I'm going to put 3.62. So one of our solutions, x equals 3.62. Anyway, now we do it for the other one. We have, of course, 5 minus root 5 over 2, because it's all the same apart from this sign here. And that is going to give us 1.381960 blah 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 blah, which is going to roughly equal 1.38. So we have x equals 1.338 and x equals 3.62. Now the quadratic formula is used when you can't factorize nicely or it's horrible. There's another way to do it as well, but just try and get your head around this quadratic formula and try some other questions on that if you would like to, because that can help you out. Now, to showcase this other method, I'm actually just going to do exactly the same question, just in a different way. Now, this is called completing the square. I don't like to use it often, but sometimes you need to, and it is quite useful. So we're going to just showcase that a little bit. To complete the square, we're just going to ignore that for a little bit, because you know, we don't need it. Pretend it's not there for a second. And we are going to take the minus 5x and we're going to halve it. So we get x, and we take the squared off. We get x minus, and then we halve this, 5 over 2. It's minus because it's minus 5. And then we put brackets around this and we square it. And then, because we've halved it, we have the other half over here, which is minus 5 over 2. We want to square that, but it's always a minus. So it's minus the other half squared. So it's quite complicated, but it's always going to be a minus, because even if that's a positive squared, negative squared, it's going to be a positive from the square, and there's going to be a minus because of this minus here. So it's x minus 5 over 2 squared minus the minus 5 over 2 squared, plus the 5 again, because we had that 5 come back from there. 5 over 2 squared is 25 over 4. Minus 25 over 4 plus 5 gets us minus 5 over 4. So we have x minus 5 over 2. You could put them in decimals if you wanted, but you don't need to. Minus 5 over 4 equals 0. So then you can add this back onto that side. So you have x minus 5 over 2 squared equals 5 over 4. Then we can square root it. X minus 5 over 2, because this whole bit squared equals root 5 over 4. Because it's a root, you need to put plus minus, because the square root of something can be positive or negative, because as we've seen before, minus 5 squared equals 25, just the same as 5 squared equals 25. So the plus minus here is important. So what we're going to have then is we can add the 5 over 2. We get x equals 5 over 2 plus minus root 5 over 4. And now that's our answer. But if it was, say, calculator, you can then put that in your calculator and you should hopefully get the same answers as we got before. 5 over 2 plus root 5 over 4, we get x equals 3.62. 5 over 2 minus root 5 over 4, and we get x equals 1.38. So it does get the same answer, and that is another way of doing it. Say on a non-calculated paper, if it asks you for one that you don't, that looks like a horrible number, you can just do this and get the square, complete the square, this is called, to get the answer. Now, also in the completed square form, which is where this equals 0, we can work out the turning point of the quadratic graph that it would be, which is, yeah. If, by the way, this shape's called a parabola, just in case you wanted to know that. So to work out the coordinates of the turning point, we of course have our coordinates thing here, and we take this and change the sign. So it's minus 5 over 2, so that's going to be positive 5 over 2 for our x coordinate. And this one, we just take it as is, we don't change the sign. So it's minus 5 over 4. So we do inside, change the sign, outside, don't change the sign, and that is our turning point for our graph. Now we can do this again, and it'll get a little bit more complicated. We go back to one of our earlier questions. We can complete the square again, and it should give us the same answer as we got before. Now this one, however, has the coefficient of 2, and we need to get rid of that. So to take the 2 out, we're going to put this. We're going to put the 2 on the outside, and we're going to have x squared, because 2x squared divided by 2 is just x squared, plus 5 over 2x, because we've taken the 2 out, plus 1, because 2 over 2 is 1. And that's what we've got so far. So now we ignore the 2 for a little bit. We can complete the square with this. So we have x plus half of 5 over 2, which is 5 over 4 squared, minus our 5 over 4 squared, plus our 1. So we've got x plus 5 over 4 squared. 5 over 4 squared is 25 over 16. Minus 25 over 16 plus 1 equals minus 9 over 16. So we have minus 9 over 16. And that equals 0. And then we can add the 2 back in, because we've got the 2 on the outside. It's always been there. It's been hiding, lurking, evil little 2. So with that, we can have 2x plus 5 over 4 squared minus 9 over 8 equals 0. So then we can add our 9 over 8, 2 x plus 5 over 4 squared equals 9 over 8. Divide by 2 again, we get x plus 5 over 4 squared equals 9 over 16. And then we square root, so we get x plus 5 over 4 equals root 9 over 16. Now you can do that because root 9 equals 3, that's a terrible square root, and root 16 equals 4. So that works. So we have root 9 over 16 just equals 3 over 4. So x plus 5 over 4, but it's also plus minus, equals plus minus 3 over 4. X equals plus minus 3 over 4. Then we subtract the 5 over 4, subtract the 5 over 4, and that is our answer. But we can work that out further because it's nice and easy and it gives us nice numbers. So I'm running out of space, so I'm going to draw an arrow up here. That was probably a bad call, but minus 3 over 4 minus 5 over 4 gives us minus 8 over 4, which literally just equals minus 2. So that's one of our solutions. And then plus 3 over 4 minus 5 over 4 gives us minus 2 over 4. 2 over 4, which equals minus 0.5. So that's our other solution. So we can use this square form to work out the solutions. And again, we can do the turning point. We have this here. So the turning point is going to be minus 5 over 4, because remember inside, change the sign, minus 9 over 8. And that is that. So there we have it. We have our turning point, we have our solutions, and we're all done. Now, the square form is not really something you need to be using if you have a nice one you can factorize like this. But if you can't factorize and it's non-calc, you probably want to use the square form. And if you need to find the turning point, that's also quite useful. So I've showed you quite a few ways here in which to solve quadratics and sort of sort yourself out with them. I haven't shown you much of graphing or square form, but they're quite complicated. So you can go and find some by yourself, or there are probably loads of past papers and everything where you can just sort of test stuff out, see what you can find, and try and do some of this stuff if you want to print it out and give it a go. But yes, thank you for watching. I hope that was helpful. I excuse my terrible handwriting and drawing and everything, but I think I've got everything right, and if I've made mistakes, then that's just embarrassing, and I'm sorry, but yeah, that's what I think. I think I've got it all right, and I hope you enjoyed, hope you found it useful, and you can always, well, I'll probably put some more videos on at some point, but this is just my first one. But thank you very much for watching. I hope you enjoyed, and if you didn't enjoy because you were just doing revision and everyone hates revision, then I hope you found it useful. So thank you very much, and goodbye.